Yeah. Many thanks for this nice introduction. As said, my name is Marco Dietz, and today we want to talk about IoT-ready building automation. I'm product manager at Thermocon Sensor Technik, and we want to show today how we could empower a traditional wired building automation system by using LoRaWAN. Just that you get an idea what you can expect within the next 20 minutes. First of all, we want to show what traditional building automation mainly is about. Then just show what Thermocon's role in this ecosystem is, that you get an impression why we are talking about building automation today, and give some business insights. And then come to the most important point and show how these traditional building automation systems can be empowered with LoRaWAN. Okay. This year's the Things conference was under the topic, or is under the topic of digital transformation. And we found a perfect fitting statement that describes exactly the issue we are confronted with in the traditional building automation. This statement says that digital transformation is about using structures of yesterday with methods of today to solve challenges of tomorrow. And now I want to show how this happens in the building automation, and therefore I want to take you to a short trip through some basics of traditional building automation. First of all, a short definition that it's clear that we are talking about the same issues. There is a difference between building automation and home automation. The main difference is the project scope. That means if we are talking about buildings, the project scope is much bigger than at home automation. Also, the users are different, and building automation projects are often realized by a kind of system integrators, and the main focus there is to reduce the operational costs for the building owner. But make sure that the technology that is used in both parts, that could be the same. During the last years, the building automation had made a development from a manual operated building to an automated operating building, and then comes to a smart building, where this smart building includes also data and things around the building, let me say, for example, like outdoor weather conditions. Even if a really smart building that is connected to the internet and can be remotely controlled is technically possible, there are many manual operated buildings in the field at the moment, still in the field. And even if these buildings are automated, the automation is oftentimes not really small, not really smart, as we perhaps have a simple time-based shutdown command at the end of the day without taking into consideration the occupancy status of a building. This is an automated building, but it's not very smart. When we are talking about building automation, we are mainly talking about these three different parts. First part is the climate control, everything that is related to heating, cooling, and ventilation. And the second and third part is the blind and the light control. It's clear that there are also other topics related to building automation, like entrance control, fire protection, but we want to focus now on these three, as these three are mainly responsible for indoor air quality and for the emissions a building has. And that is, let me say, the main goal of a smart building, that we could reduce the emissions that the building occurs, and also to improve the indoor air quality. How does a traditional building automation system then looks like? A traditional building automation system is typical hierarchical. That means at the bottom you have the field layer, where you have installed the devices like sensors or input devices for the building automation. These devices are then connected to the automation layer, where the logical control is done. And this automation layer then is combined in the control layer, where you have a kind of supervision system. Thermocon's role at this ecosystem, we are providing solutions for building automation on the field layer since now 35 years. That means we building sensor solutions and also room operating unit solutions who are taking part in this ecosystem. If we are doing so, it's clear that our components have to have structured communication processes that we can ensure that our devices can communicate within a standardized building automation system. So there are many different field communication systems at the moment existing in the field. The first part, or let me say the oldest part, are simple digital or analog outputs, just switching on and off something. And the easiness of these systems is also the biggest advantage. That means you don't need experts to install them. And as they are so simple, they are also widely used in new projects today. The second part of field communication systems then are traditional wired bus systems. These bus systems are used if you want to transmit more, say complex data. And each of these different bus systems has become a kind of standard in different building applications. Just to give an example, if we are talking about the DALI bus system, DALI is mainly used in high-quality lighting applications, and the BACnet wired system is mainly used in everything that is related to heating, ventilation, and air conditioning. That brings me to the third big group of communication systems in the building. These are the wireless systems. Each of these wireless systems also has its main application. If we are talking about an ocean, then we're talking about energy self-sufficient devices. That means you don't have to care at these devices about battery lifetime or about a power supply, as these devices could operate energy self-sufficient. If we need more higher data rate, then Wi-Fi comes into the game. And if we want to cover long ranges, if we have, let me say, big buildings or need an IoT-ready protocol, then LoRaWAN is perfectly fitted. Now, if you see all these different field communication systems, then it becomes clear that inside a building, everything is about interconnection. That means you need systems that can communicate with other systems, as it's hardly possible to find one communication system in a building that covers all requirements. These requirements in the building are sometimes very complex and very different. There are many questions that have to be answered before choosing the right communication system. Just to give an example, is it a retrofit project, or are we talking about completely new construction? If we are talking about wireless systems, then oftentimes the question occurs, is a cloud application for the customer possible, or does he need an on-premise application? So also the application type is a very important reason. If we are talking about soft real-time applications in building automation, we are talking mainly about blind and light control, where the user normally expects a direct response from the building. That means if I push the light button, I expect the light to be on within the next 200 milliseconds. So if we have this application, then we can choose for an event-driven communication system like KNX, or for a wireless system like an Ocean, which has very low latency times. If we then, on the other hand, talking about applications where a higher latency time is no problem, for example, a heating system, where it doesn't matter if the heating turns on 5 seconds later or earlier or a minute later, then also, let me say, slower bus protocol like Modbus is no problem, or the duty cycle restrictions of LoRaWAN also are no problem. So this was just to make clear that there are many questions to answer before choosing the communication protocol for a real smart building. Besides the control system in the building, there are also other systems existing. Nearly every smart or nearly every commercial building has an own IT system. And the issue we are faced in the field is oftentimes that these systems are independent from each other. That means there are different responsibilities for this system. They are locked to each other, and it's very hard to get access to such a system if you need their infrastructure. Sometimes this leads to some curiosities. As you've seen on the right-hand side, it was from a real project we were faced with. There you see 4 sensors or 2 occupancy sensors mounted on the same position, but they belong to different systems. So if you're talking about green buildings or smart buildings, it is not very smart to put 2 times the same sensor to get 1 signal out of the room. But there are different responsibilities. The systems are not able to communicate with each other, so there was no other possibility to do so. There are also some other points very important in the building automation. At the moment, building automation, there's a very systematic and long-time tender procedures. That means there are many participants along the chain that you have to be convinced if you want to introduce a new technology, and that sometimes makes smart building applications a little bit slow. Also, if we are talking then on-site construction, we have divided ecosystems. That means if you want to install a technology that belongs to different ecosystems, it can cause some struggles on-site construction later. Many buildings are also, at the moment, operated by data point-driven business models. That means the owner has to pay for every data point he needs in his building automation system. And so the system integrator is asked to, to build up the building solution just for the minimum needs for a sensible automation. But these buildings could not offer their whole potential. Perhaps sometimes there's just 1 data point missing to make a regulation really smart, and it's oftentimes not possible to get these data points, as in the earlier stage they were not agreed to put these data points to the business model. And one of the most important parts, the most important points, is that nowadays there are many existing buildings out in the field which are using exactly this wired traditional building automation systems. And if there comes a new technology that wants to be successful, even in this vertical, such a technology can't ignore the actual state. Otherwise, it won't be so successful. Now we come to the point where we want to show our approach, how we could combine the existing traditional building automation with the LoRaWAN. We have decided to implement the LoRaWAN connectivity on the field layer and not putting a kind of IoT framework on the control layer. And now I want to show why we have done this and how we have done this. Here we see just an exemplary example for a traditional building management system. You have in the upper part a building management controller where a room operating unit is connected directly via a wired Modbus and communication interface. Then you give the inputs from the room operating unit to the controller, and this controller controls then the climate control, the ventilation, the light, and the blinds. That means we have in the room very low latency times, we have a familiar user interface, and this is the, let me say, single room automation solution. If you now add a LoRaWAN connectivity at the point of the room operating unit, you have the possibility to get all the data out of a room directly into a LoRaWAN-based IoT application. That means you can fetch all the sensor values the room gives you. You also can fetch the actual state of the lights, the blinds, and the ventilation system. And on the other way, you can also put some override commands. That means you can put really smart control commands back to the system via using the LoRaWAN ecosystem. I hope that it now becomes clear how we show how both systems, the IT system and the control system, could find together in, let me say, one device. And the main advantage here is that the existing building management system could stay as it is. That means you don't need physical access directly to the building management system. You don't have to change any components. You don't have to replace everything, but you are relatively fast with deploying this solution. Why have we chosen for implementing this into the room operating unit? The room operating unit is one of the central points in a building automation, as this is the point where the user directly gives the input and gets the feedback from the system. So this user interface, the user is very familiar with. And so if we don't have to change anything and this user interface could stay as it is, that is very nice for the user. Also, you have, for the room control solution on-site, a very low latency time. That means if you go to the room operating unit, switch the light on, there is no latency time in between as the on-site control stays as it is. And if we're fetching all this data from the room operating unit, the enablement of IoT-based services like dashboards, AI optimization, whatever, is very easy possible. And also you can use the existing structures that we have today out in the field, and you don't have to change all these components. Yeah, we have now seen an example for the right part, where we have shown this approach for a wired traditional building automation system. This is also possible for wireless systems. If you are talking about an ocean is oftentimes used for single-room automation systems, especially for retrofit projects where it is not possible to install afterwards a big building management system. So now we are adding an interface to LoRaWAN and just fetching the data that are necessary for monitoring or for override functionalities. That means the on-site traffic for the regulation is done on-site via NOcean, low latency times, and you can use the whole NOcean portfolio that is existing in a building, and you just use the power of LoRaWAN for the remote monitoring and, let me say, for the remote control. So referring back to the slogan we had at the beginning, I hope that it now becomes clear how LoRaWAN could use the structures of yesterday. That means the existing buildings, put the power that this ecosystem has nowadays to solve the challenges of tomorrow, and I guess these challenges are quite obvious for every one of us. So from my side, many thanks for first time for your attention. I would heartily invite you to come to our booth B02 and to have this this solution we have shown here as a live demonstration. If you have any questions, then just come by, and you can also contact me afterwards via mail or LinkedIn. Many thanks.